In this module we're going to talk about read preferences a little bit. What we're going to focus on here today is for availability. There are many reasons to set a read preference, many reasons to use a read preference, but from an operational perspective, you may use read preferences purely from an availability perspective. And remember, we're deploying primary, secondary, we're repeating this ad nauseum for sharded clusters. The first thing to note is that the default read preference is primary, and that means that all reads go just there, to the primary. The primary is unavailable. For example, if two of the nodes in this set fail, this has to step down and become a secondary. Your driver will throw an error and say no primary available, or it might even be an even older message, no master available for that particular replica set. If there's no primary available, you're going to get an error here. And there's good reasons for that to be the default. If you are going to read from a secondary, the major caveat is eventual consistency. If you have not built in the capability to handle eventual consistency, a write or an operation here may not immediately show up on a secondary. There could be a delay. They will eventually catch up, hence eventual consistency, but a write here does not necessarily immediately show up in the secondary, and so if you do a read from the secondary, you get the expected result. So eventual consistency is something that you have to plan around. It is something that your application must be capable of doing, or you can't take advantage of some of the other features that we're about to talk about. And that's why our default read preference is primary. That's why that is the default way that your driver, your application will interact with a replica set. But there are other options. So the default, as we just mentioned, is primary, or if you want to be a bit more specific, primary only. Our other options are primary preferred, secondary, be explicit secondary only, secondary preferred, and nearest. All of these options, except for primary itself, can take advantage of some of the redundancy that's built into a replica set. Primary preferred, for example, if the primary goes away, and indeed the secondary goes away, and no new primary is elected, primary preferred will allow you to read from this secondary here, the one remaining one that's up. If you'd set primary, you would have gotten an error. Hence, you've got a better range of availability by using primary preferred. The downside to that, of course, is that you're going to have to build a more complex application to deal with the eventual consistency model, and you're only taking advantage of that in the event of an outage. You're doing any of that extra work, whatever extra work is required for your application to deal successfully with eventual consistency, whatever that requires, you're only doing that for sort of your edge case usage. So you have to make a cost-benefit trade-off analysis there to see if that's actually worth your while doing. The next one up is secondary only, and this is where your writes are pounding your primary, and you want to make sure that your primary is focusing solely on doing writes, and you say, okay, I'm going to do all my reads from secondaries. Or maybe you've got one application that has to read from the primary. In other words, you've got an application that cannot deal with eventual consistency. So that sort of primary application, so we'll call that the p.app, must read from here, and it's going to use our default primary only read preference. That a primary app is there, but you've got a secondary app here as well. Maybe it's analytics, something that's not as sensitive to the eventual consistency model that you're going to need to be able to deal with if you're going to read from secondaries. And in that case, because this is a more suited application, you say secondary only. I don't want this to impact my primary at all, so I'm going to send all reads to just the secondaries from that secondary app, and that's where we get secondary only. So we've covered the default, we've covered primary preferred, and we've covered secondary only. And that seems a little bit limiting. Maybe you want to keep this away from your secondaries completely, but what if there's no secondaries available? What if the only thing there is a primary? And that's more likely to happen in this type of scenario. Let's say you have a primary, a secondary, and an arbiter. Now, in this case, if you're using secondary only, so let's say it's still this secondary app that we were talking about that's okay with eventual consistency. All of its reads are going here, none of them are impacting the primary, you're doing what you expect to do, and this secondary goes down. Now you still have a functioning replica set, albeit one that's more of a risk now, but this secondary app, the one that's okay with our eventual consistency model, now has nothing to read from. The arbiter doesn't carry any data, and we've set secondary only, so it can't go to the primary. So in this kind of even more niche scenario, you can imagine that using a secondary preferred read preference might be your best bet. And in that case, when the secondary goes down, if you're using secondary preferred, it goes, oh, okay, well, I'm just going to read from the primary for now because I still want this app to actually function. So it just gives it the option to fall back to the primary if the secondary should disappear for some reason. That's secondary preferred. So as you can see, between secondary and secondary preferred, in this particular scenario, you get a better availability model by using it. So you improve your availability in this particular model by using it. It's not always the case. Losing one secondary, losing the second secondary would, in a normal 3-node set, primary, secondary, would reduce the primary to a secondary, in which case secondary only will continue to work. It is very much an edge case where it increases your availability here, but just thought I'd mention that particular scenario just so you're aware of it. The final read preference is basically the most flexible of them all, and that is nearest. You got a primary, secondary. We've got an application here. When you use the nearest read preference, it will actually figure out which one of these is closest and read from it. So if it's this secondary, it will read from here. If it's this secondary, it will read from here. If it's the primary, it will read from the primary. So nearest is really just give me the closest one to me. And where it comes into its own, of course, is when you've got geographically distributed replica sets. So let's say, this secondary is in EMEA. This one's in the US, as is the primary. This application is from EMEA as well, Europe. So when it looks to see what's closest, it finds the secondary and it's allowed to read from that. Again, when you're using nearest, eventual consistency has to be part of your mindset, has to be part of your application design. Your application must be okay with reading from a secondary, writing to the primary, and having the delay. So there you go. Those are your read preferences from an availability perspective and sort of the options it gives you. The default is the right choice for most people, reading and writing from the same spot. If you've got availability concerns, you want to be able to do failover, or you want to be able to read from the nearest node, you've now got a good idea of the options that the different read preferences will give you.